Hi everyone, my name is Dean and you're listening to the MLOps podcast. As you probably know, machine learning in general and data science are two fields that are evolving all the time, and it's really hard to keep up to date. Specifically, the area of bringing machine learning into production or into the real world seems like it's very confusing. There's a lot going on and it's hard to make sense of all that's happening around you. But on the other hand, there are a lot of smart people that are doing great work in bringing their own projects into production. And we've had a chance to speak with a lot of these people, but it definitely seems like the information is not widespread enough and a lot of people don't know of best practices and how other teams work. So that's why we decided to start this podcast, where we'll be speaking with people who are working in various types of machine learning teams and hearing about how they are bringing their projects into production. I hope you find this interesting, and let's get started. So, hi everyone, and welcome to the MLOps podcast. I'm your host, Dean, and today I have Roey Mechrez with me. Roey is the CTO and co-founder of BeyondMinds, where he leads a team of AI researchers, scientists, and engineers. Before that, he was a researcher at IBM and a company called RSIP Vision, and he's taught courses in computer vision and deep learning in the Technion, which is the Israel Institute of Technology. He also holds a Ph.D. in electrical engineering from the Technion, and he is the first doctor on our podcast. So I'm really happy to have you on, and thank you for taking the time, Roy.
Thank you, Dean. It's lovely to be here, and thank you for inviting me, and looking forward for our discussion.
Awesome. So BeyondMinds is a very interesting company that I am familiar with for a while now, but it would be awesome if you could introduce the company and what you're doing there to the audience.
Yeah, sure. So BeyondMinds is a startup company based in Israel. We are 3 years old. And till today, it was a fantastic journey with amazing people. BeyondMinds is focusing on enterprise AI, and we provide end-to-end solution for enterprises, mainly in manufacturing, Industry 4.0, and financial services. And we're focusing on end-to-end solution. We provide this solution as a SaaS service, and we're trying to bridge the gap between amazing research, academic breakthroughs, into the real world, into production. Yeah, so we're focusing on many different areas along the development cycle and production cycle of an AI solution. Not only about building the models, where I think till today there was a significant effort, but more over the production elements of solutions. The basic product that we are developing is the BeyondMinds platform. Is a platform that enables us to productize faster and better AI solution. I assume you are familiar with the bad statistics around bringing AI to production. That's the basic problem that we're trying to solve. The fact that only 1 out of 10 solutions or projects in AI actually reach production. And we are trying to break that statistics and change this systematic failure into a systematic success. So we have developed the BeyondMinds platform, which composed of many different components relevant for production, such as monitoring, retraining, and many different elements that, if you want, we can dive deeper into in our discussion today. But the basic idea is that, okay, you have a model, you have a great data science team that developed this model, but that's only one component out of a complete system that is needed to productize an AI solution. Definitely when it goes to industry and financial services, where it's in many cases not super simple solutions and use cases.
I'm guessing that there's a lot of issue with like regulations in those organizations as well that you need to solve for.
Yeah, I guess regulation is one element that must be addressed, right? So if you take that into privacy, data-related use case in financial services, you must make sure that there is a fairness or bias-free solution, right? You want to add into the model components like explainability and confidence estimation, and have a decent monitoring and make sure that you have governance mechanism around what data is being used and data leakage, etc. So all these components are wrapping the models and make it usable and achievable for what these institutions and enterprises needed. And think about throwing you back into this failure rate, right? Think about a data science team that is trying to build such a solution from scratch, right? They need to develop so many different components. Okay, so they have the classifier or the regression model, but then you have confidence estimation and monitoring and explainability and so many different components that are needed. And then when you develop so many different components from scratch again and again, that takes a lot of time and you have a high risk of failure somewhere.
Yeah, I mean, the higher you raise the complexity level, the more pitfalls you have. I guess I'm curious because this actually came up in the last episode, which while we're recording this is not yet out, but the definition of what is an end-to-end platform. So I'm curious specifically, when you say end-to-end, is your user the data scientist, an analyst within the organization, or someone else?
Yeah, that's a good question. So I think out there in the world of B2D, business to developers, there are lots of amazing tools. I wouldn't say names here, but I think there are so many different tools, platforms, products that make the life and work of a data scientist much, much easier. BeyondMinds' focus is on the line of business executives. And we're trying to bring business solution and not developer tools. So our users can be different personnel around the business. Take defect detection as a simple example in manufacturing. There is an operator somewhere in the production line that used to check defects manually, and now he does that with an automatic process. And he gets a suggestion from a system, and he needs to sit near a monitor and verify and be the human in the loop that makes sure that the system is now work. So I guess different kinds of operators, people that have a profession in doing actual work. I don't know, a claim assessor, a fraud investigation team, and onboarding KYC, know your customer elements in financial services. This type of people are the people that use AI solution. They're the end users, and they're our focus.
Okay, that's very cool. And it sounds like from the examples you described, I don't know if those are specific examples that you're actually working on, but do you have a domain or a data domain that you're specializing in, or do you actually do projects across all of these different domains?
Yeah, I think it's one of the most interesting points about BeyondMinds. I think very early on, we took a decision to be a horizontal platform. To those of you at home that are building startups and trying to develop products, horizontal is raising the bar of complexity because you need to solve many problems in a very generic way. So at BeyondMinds, we're doing computer vision solution, we're doing natural language process solution, we're doing some time series solutions, and we're trying to generalize what is common to all these projects as much as possible and put that in our platform. Can take one very important factor as an example, which is retraining of models. Right? Our basic assumption about the reality is that AI as a data-driven solution is very based on the data, and the data is a dynamic creature. Okay, so unlike the lab where the data is static, in the production environment, the data is changing over time. If the data is changing over time, the model should be dynamic as well. If the model should be dynamic as well, what tools do you have in order to retrain it, in order to make it a dynamic creature as well? And I think one of the barriers that we see today across companies and enterprises is that maintenance is a very heavy, costly element of AI. So the success stories where people already put a solution in production, they have a very high maintenance cost that they need to retrain the models again and again and again. I have a very bad example for you if you want in the defect detection domain, where the data was changing every few months, and the team that was working on that needed to recollect data, annotate, retrain the model, and that's actually this long cycle just prevent the model from being actively used, because okay, how can you trust a system that every 2 months need to be retrained for a week, right? It's the retraining is the easy part, but you need to collect the data, annotate the data. So, for example, what we have done in the BeyondMinds platform, so we have the entire life cycle of this retraining, including collecting feedback from operators, including the annotation, specialized on these data drifts, these new cases, these low confidence cases that we are collecting, aggregating, and then we are initiating a retraining process, validation of the new model, and deployment of the new model, all in the platform. So that's a very significant element that help teams to do this maintenance and production cycle over again without significant effort. So I think that's a super critical element of our platform that is part of production and must be addressed early as possible.
Interesting. And so all of you said a lot of terms which are obviously very familiar to people who are data scientists and machine learning engineers. Yeah. But like you said, you're serving people that sometimes, or maybe most times, aren't familiar with those terms. So I'm just curious in the sense of communication, which is obviously important in all walks of life. Like, how do you communicate something to the customer? Like, you need to give us feedback on a regular basis, otherwise your model is going to be bad. And the moment you realize it, it's going to be too late to fix it. So how does that process look like?
Yeah,
if you had the chance to take part in it, I don't know.
That's an interesting question. So I can give you a few perspectives on that. The first one is that unlike, let's say, the previous decade, I think the point where we stand today, executives and managers and people that lead the AI in the organization have quite good experience and understanding of what AI can do, what is its limitation. I think if you go to a McKinsey survey from 3 years ago, you will find lack of understanding as one of the main barriers in adopting AI. But I think we're totally past that element. The amount of knowledge, materials, thought leadership articles that are out there is enormous, and conferences are like every day there is an AI conference about something. So I think people are progressing, and they have much better understanding of the limitation and the capabilities. That's on one hand. On the other hand, we worked very closely with customers to visualize, to try to build the big picture of what this solution is going to look like, what are all the components, how that's going to be integrated, who is going to use that, what is the human in the loop interaction, how to build this trustful human-machine collaboration as one of the main components of success in AI. So it's involved a lot of effort in communication, in materials, in thinking about all the fine elements. We have delivery managers that are engineers in their background that help us doing that. And there are product managers that involved, and of course, research team, engineers. So it's entire ecosystem that you need to bring into place in order to to have a successful solution.
Yeah, that makes sense. I'm also it's sort of one of these interesting things that we've been thinking about recently is in products where AI is or ML whatever is a tool that's supposed to help the user do something which is part of their business work. Like how important is it for the user to know that AI is even involved? Because when you think about it, like there are a lot of use cases where magical things happen engineering wise behind the scenes. I'm talking about like generally in systems where like very complex algorithms are used for different things and the user has no idea that's happening. Now, obviously, AI is sort of very hot right now in many ways. But I'm curious to hear your thoughts. If you feel like in 10 years, you wouldn't even need to explain it to users because no one would know. They just use it and get the features and that would be an implementation detail.
Yeah, I think it's a good perspective. So I think the world is changing all the time. We see more and more advanced. There is AI in more and more elements, right? Many people open their phones with AI hundreds of times a day, and that become more and more popular, more and more understandable. But still, I think when you change a business process, when you change operation activity, when something is dramatically changed in an organization, people need education. They need to understand how it works, and I think that this human-machine collaboration is really critical. And as far as my understanding, if you will build more and more bridges between the human and the machine in the development, in the way it works, there is more chance to success. And if you go and look at the, let's say, big 5 technology company, you will find strategies specifically tailored and developed and written about the way people interact with AI, things to take into consideration, what questions to ask, how the end user will use it, what's going to be the feedback, is it going to be validated over time, etc., etc. I think it's critical for success. And many of the elements that we are developing in our platform are related to the end user, the one that is going to use the AI, such as dashboards, statistics, insights, understanding what's going on under the hood, be able to see, visualize an API. I want to see all the data that comes in, to have the possibility to look at each sample, to make sure that it was valid input, right? That the system is not getting garbage, so garbage is not coming out, etc., right? And to those of you who are a data scientists or engineers, right, the concept of garbage in, garbage out is very, very clear, right? We want to make sure that no garbage is going into the system. And I think in AI, it's even stronger because most models, if they're going to get garbage in, they will give you garbage out, and you won't even know about that, right? When AI it fails silently. And many of the production grade elements that are needed are to fight against this problem, right? This stability, sustainability problem that we build a system, we put it in production, we want to make sure that it will be valid over time, that it won't get garbage, that it won't fail. What's happening in real scenarios, when the data is changing, when something is happening, can we react? Can we make sure that the model is on the rails? And I think this is one of the element that I see reason for failure today. And well, that's what we're trying to solve with the platform. But I think also I see more and more teams that are trying to address it systematically. And take the development one step ahead of building models.
Okay, so you mentioned now a lot of components, right? And again, this is part of the challenge of providing sort of this end-to-end experience. And I think sort of just to name a few, you mentioned first, you have less maybe technical users, you have to monitor results, you have to automatically, like when there's an update or feedback from the user, you need to automatically productionize or deploy a new version of the model. What's the hardest part of all of these? Like what's the biggest challenge you faced as part of taking machine learning models into production?
Well, the easy answer is orchestration.
Interesting. Okay.
Because each one of these components is solvable, right? You will bring engineers, you will bring data scientists, give them a problem, they will solve it, right? That's what engineering is all about. But having one problem and another problem and another problem, they're all related to the same product and the same development, and now wrap that systematically together again and again and again in a scalable way. That's the challenge, right? That's the challenge that I'm thinking about every day. That's what we are trying to accomplish, and I think wherever I look, we work mainly, let's say, with the global 2000 companies, and if you look at global 2000 companies, they don't really care about a single AI solution. Well, maybe some people do, but what they care about is AI adoption, is competitive edge, is how to bring more and more AI into production, right? I think Facebook published a blog a few weeks ago about their shift into PyTorch for production. And they published some statistic about the amount of models they have in production, and it's in thousands, right? I don't know many companies around outside the technology sector that has thousands of models in production, right? That's a complete the level of complexity needed to have thousands of models in production is so high that that's where the focus should be, right? It's not about another model and another model and another model in a non-scalable way that will break, right? Go back to the defect detection example that I gave about the maintenance 10 minutes ago. So what? I need like more and more people for each model I deploy, for each model I have to deal with this maintenance updates. I have a team that build the models. I have a team that maintain the model. And probably as an engineer, that data scientists, the worst work that the work that they hate the most is maintenance, right? That's probably for anyone, right? Throwing you back to something you've done 3 months ago. That's a nightmare. And this is the effort, right? Scale AI adoption, right? What are the tools that I need to that? And again, and I emphasizing, I think building the model is only grade one, right? It's only the first step. That I think becoming scalable, right? If you have a developer platform, amazing, you have data science team, they will bring you models with a decent speed even. But what are all the rest of the components? So orchestration, but if you want to take it into the research area, I think monitoring insight is a very hard problem to be able to not do monitoring on the, let's say, a very shallow statistic level, logging, alerting, rather bringing actual insights or observations, as the industry like to call it. I think this retraining without forgetting is another research challenge. So you have a model, you had 1,000 samples, you trained it, you have great accuracy. Now you have 5 new samples that the model didn't succeed on. So you have 1,005. How you build a better model that will be good on the 1,000, but will be now also good on the 5 new cases that it wasn't good on. That's completely unsolved or unresearched problem in the research community. And I can give more readers if you want, but I think these are two critical research areas that we are working on, and I think they're how to solve with the orchestration, of course.
Okay, interesting. So maybe we can dive into all three of them. I think they're all really interesting. I think the first two are obviously very case specific, and they're not surprising. Like, I'm guessing that the details are interesting and surprising, so we'll dive into them as well. I think the third thing that you mentioned is interesting and surprising, because it's one of those issues where you say, well, if I train a model on 1,000 instances, how bad could it be to just add a few more instances, right? It shouldn't be like an order of magnitude more complex. But obviously, the moment you try to dive into it and sort of think about what that means, then you discover it's not that simple. So maybe let's start with a surprising one. So why is that a hard problem, and how do you deal with it internally?
Yeah, I guess if you will go to a data scientist and you give him this problem, probably the non-patent solution that is someone that that will be the first solution as the most common sense scenario will be, okay, just do fine tune, right? You had 1,000, you trained the model, now we have 1,005. Just do a few more iteration, run the data one more time, and you will get a better model, right? Well, that's unlikely to happen in a very good way, because if the model got success on these new 5 samples, and now you have 1,005, it's unlikely that suddenly it will be able to generalize to 1,005. Maybe if it's like really near the distribution, but in most chances that it will or harm the model or won't do anything. And then you can, re-emphasize these 5, so give them more weight or something like that. Show them again and again to the model, build a new branch. There are many, many different solutions, but then you have the risk of forgetting, right? It could happen that you will overfit on these 5 and will harm the 1,000, right? So it's the short blanket scenario as a problem, right? It's a generalization problem. And it's definitely not a simple one to solve. Now, let's take it even to a harder problem. I want, as part of my platform, I'm trying to solve it in a unseen way. That means there is no data scientist in the loop that is now looking at this 1,005 and tune some parameters to achieve this amazing solution that will work for 1,005, because I think that's possible, right? Run, 100 experiments with different parameters, you will find the best solution for this 1,005 samples. But can you do that automatically? Because that's the problem statement, right? I want a system that an operator can mark 5 new samples, right? Tell the system you have mistakes here and give me a better solution, give me a better model, right? That's the problem statement. And that's a vague area in the research. I think this is something that is an amazing breakthrough. I wouldn't say that we solve all the elements of it, but we're working on that. That's an amazing research journey. We have lots of different components that some of them I won't tell you that are in place, and it doesn't end there, right? Because I gave you a very simple case where it's a binary classification, but what if it's a new label, maybe a new class that is coming in? So you need to use some kind of few-shot learning, how you add new class, how you balance that system. And there are many different scenarios that can happen in production that you want to make sure that you can cover. And I think that's a super challenging element. Definitely, if you like to generalize.
Can you maybe, without sharing anything secret, let's assume I'm a data scientist in a company, and I'm trying to automate it, not necessarily in the sense that I even have end users that need to do it by themselves and they're not technical, but just in the sense of I have a model in production and I want to be able to automate modifying it for these edge cases. Like, can you give us a hint on where can we start this journey?
Yeah, well, I will use other words. You probably listen occasionally to Andrew Yang, and is says about data, right? So data is the king here, and I think when you go into this problem, you need to understand your data, right? What was the original distribution? Where the new sample sits on this distribution? Is it even possible? What is the distance between the new samples and your original data? If it's too far, it's unlikely to be solvable. If it's close to the distribution, maybe you need more samples around this area. Can you resample the data? Can you bring more examples that are similar to that? Can you control the data that you're going to train on? And bring quality data that will enable your distribution, and of course do that automatically. Ask the user for more samples like that. Ask feedback on specific cases. I think these are the areas for solutions. And it's not throwing the research problem on just bring me more data, because what kind of data? How you measure similarity? How many iteration you need, etc. I think these are the interesting area to look at, and some of them are solvable very nicely. Even thinking about these elements in a distribution way of thinking. What is my distribution, right? Which is clearly not accessible, but can you try to understand how the distribution looks like? What is the limitation of the system? I think one of the areas that I like the most is out of distribution detection. And going back to this garbage in, garbage out problem. Let's make sure that only in distribution samples will go into the model. And then again, measuring a new sample, if it's within the distribution or not. And if it is, I can automate that quite easily. If it's outside the distribution, it's likely to fail. And then I can use that data later on to increase the distribution. So there are different ways to understand your data as an input, but also an output with confidence estimation elements and post analysis, let's say. But I think these are the vague examples and the directions that I can talk about.
So this is really interesting. Maybe I'll share an example that we just had a similar discussion, and I think this also connects to the second challenge that you discussed, which is sort of generating insights and observations out of the monitoring system. So maybe you're not just monitoring the model outputs, you're monitoring also the inputs. And so we had a conversation with one of our users who, again, some of this information is sensitive, so I won't share everything, but he's working in the medical imaging domain. And they have this challenge where they're training some model, and some of the samples the model doesn't perform as well. And so they have a manual step where after training, they validate the model, they look at the samples where the model wasn't as good, and then they go back to the domain experts and give them examples and ask them to get more data, which is corresponding to these types of samples. And one of the challenges, like when you were talking about automating this, is basically if you are automating this, how do you generate from these bad samples an explanation that the end user can understand, like, oh, this is the issue and this is what I need more data of?
Yeah. This problem is repeating itself all over again, all over the place, right? It's a very basic element. And I think it goes into one of the most simple elements, which is representation and similarity measures, right? Sorry if I'm going too deep technically, but
No, this is great.
Your ability to represent an image, a sample as a vector, right? That's critical elements in deep learning, in AI, right? And measure similarity to other instances, right? Where I'm related to this, right? And I think there are many techniques. I think the entire face recognition domain is all about measuring similarity between faces, between a face and a data set, one versus many, whatever. And there are many other similarity measures, techniques out there that can be think of. Some of them are more unsupervised way, etc. You can use advanced loss functions just to build a good representation and a good similarity when it comes to autoencoders, variational autoencoders. It's all about similarity, basically. It's all about representation, and I think that's a big element that can solve lots of these problems, and try to bring similar examples. And of course, in a very expert-related, such as medical domain, that you need an expert to make sure that you're bringing similar and quality data. So you need to build this human in the loop. Not everything can be automated, right? But how you use the human in the loop smartly, I think it's a good question. And if you listen to podcasts, so I recommend listening to. Sorry if I'm sending people to other podcasts.
No. I love podcasts. I recommend one at the end of every episode, basically.
Yeah. So read about Verbit, right? I think that's exactly what we're trying to do, right? How to bring the human into the loop, right? Given the fact that AI is not sufficient, it cannot achieve this 99% accuracy that is needed for this use case. How you take an AI that produced 90% and add 10% human to achieve 100? That's I think one of the questions in AI in 2021. Human-machine collaboration, right? Around data, around stability, around sustainability. You want to retrain a model. You want to be able to show the user relevant monitoring elements that he can take actions. This is the holy grail of the field, and this is, I think, where we are putting our research effort. But I think this is where I recommend scale, people that look for scale, to emphasize their research in the product side.
Interesting. Yeah, I'm still imagining so first you mentioned Verbit. So just for the audience that maybe haven't heard of the company, Verbit does sort of transcription services. So you can speech to text, basically. You give it an audio file and you get the text behind it. And obviously it's an ancient work that people used to do manually. Now machines can get us a pretty incredible percent of the way there. But one of the interesting things about that company is that they emphasize that it's not fully automated. Like, they still have humans in the loop in order to get the best results. And I think that's first, I think it's positive in the sense of like being honest about what we can and can't do right now with machines. Again, like if you try one of these speech to text models, you will be impressed. It's very, very amazing. Like, it's really amazing that you can do these things without involving any humans, but then you do need that additional human touch to get the finer details. But I'm still, so another famous model that's recently made waves is DALL-E. So it's an OpenAI model, which is basically combining text input and image generation, where the idea is you give it a prompt and then it creates a very interesting, somewhat hallucinogenic image of that prompt, and maybe the solution in the longer term is something like the opposite. So you would give it an image and it would find what describes why this is not similar to the other images within the domain. So maybe that's science fiction right now, but I mean, I feel like that's a very big challenge in human in the loop, because if you look at these, for example, let's stick with the medical domain, there might be a lot of different reasons why an image, like a model didn't perform well on a given image. And the ability to explain, like maybe the image has a bunch of bad factors, like it's low quality, or there's like, I don't know, smudging, blurring, whatever. Or it just might be that you labeled half a sample and half of the sample wasn't labeled. So there was an issue with the labeling. And how do you pinpoint that if it's not immediately obvious? I agree with you that sounds like an incredible challenge.
So I can give you, I totally agree. I think it's one of the most interesting problems of the field, and this is the work of a data scientist involve a lot of this data crunching elements. I think we gave lots of image-related samples. I can give you another NLP-based sample to bring the other side of the audience into the game. But if you look, for example, on question answering problem, right? You have a paragraph, you have a question, and you want to find the answer within this paragraph, and you look at what happened to models that were trained on the Squad dataset, which is based on Wikipedia, and you took these models into a different domain, such as Amazon Review or Reddit. You see across all models a degradation of around 10%. And it's very surprisingly to see the linear curve that these models are on. So model that was better on Wikipedia is better on Reddit as well versus other models, but still all of them degrade in more or less constant. And this domain shift, this distribution shift, something that is happening in production, unfortunately, that we must address, right? And okay, so you can say, okay, then take the two data sets and train a bigger, stronger model that will generalize. But that's first of all, it's very hard. Second of all, you need your actual data for question answering. Annotation is probably one of the most time-consuming, hardest annotation possible. But it's so hard to bring more and more data from different domains and build this super generalized model, GPT-3 for whatever that works on everything. And I think part of our work as a data scientist is to narrow down the problem as much as possible. And in many cases, I usually tell my team that overfitting is bad in general, but if you have a narrow problem, you want a semi-overfitted model, right? You want a model that will be perfect on what it needs to be, on the distribution that you got, and to understand what are the distribution that it can meet in production, but not more than that, right? And you find researchers dealing a lot with augmentations and different techniques to enrich the data. And the only reason they do that is exactly to solve this distribution problem, this generalization problem, to make sure that if 100%, 180 degrees rotation is not possible in production, it doesn't make sense to augment the data in this way, right? Just because it's possible in the computer. So I think that's exactly what is needed when building a model. And the question is how to do that faster and better and make sure that you are really solving the problem. By the way, make sure that you really solve the problem is also hard.
That's true. I mean, I think you're speaking to a point which is maybe I don't know if the word is ideal, but the ideal goals for data science or machine learning project aren't necessarily the ideal goals for a product. And so you need to be able to separate those two and remember, like in some cases, the research goal is the important part. In others, you want to solve a real problem, and then you might have the state-of-the-art result for some task, but if it doesn't solve the problem for the end user, then it's not, I mean, maybe you publish a paper, which is always good, but it's not going to serve the product that you're trying to build. And I think that's definitely something that we need to be aware of. So maybe to get to the last point that you spoke about, so orchestration. Obviously, orchestration is a problem that becomes harder the more complex the system you're trying to deploy. And from what you've told us so far, it seems that you're trying to deploy a pretty complex system. So maybe if you can share a bit about how that works at BeyondMinds. And also, if I understand correctly, you have sort of these custom flavors of your platform for different companies and sort of domains. So how does that customization process look when it's automated, if it's automated?
Yeah, let me start with the customization problem, because I think it's a more straightforward answer, although it's very interesting one. I think, again, I throw you back 3 years ago when we incubated the product and tried to understand what are feasible assumptions. And one of the most critical assumptions that I have on the world, and I think it's a very strong one that everybody can relate it, is specificity. Problems are specific, right? And that comes in a very strong conflict with product, right? If I'm saying problems are specific and I want to build a product that will solve all these specific problems, there is an inherent problem here, right? And that's what we're trying to build in this horizontal platform, try to generalize as much as possible to the problems that are specific. The data is specific, the constraints are specific, the requirements are specific, the business the business process is specific, right? So this assumption, this specificity of problems, the problems differ between company to company, even if it sounds exactly the same problem, by the way. This brings us to the need for customization, right? It's a must. Andres and Horowitz call it, they have a really cool blog about entrepreneurships and AI. If you want, we can put the link here afterwards, but they call it the long tail problem of AI. Basically, that each problem is a little bit different and it's create a long tail of the problems. And if you have a long tail, it's hard to build a product, right? So at BeyondMinds, when we designed the platform, we took into consideration that we will have to do customization. We even call it hyper customization, because I want to give my customers a silver bullet. I'm dealing with enterprises. I want to make sure that they will be happy with the results. On the other hand, I want to make sure that I'm not developing from scratch, right? Because if I'm developing from scratch, I'm no good than any other team that is just developing a solution. And combining these two elements together, I want customization, but I want production grade, not developing from scratch. We developed a platform that solves many components, and in customization, I'm bringing together many components. So it's an orchestration game, connected to your first question. So the orchestration is the heart of being able to do customization at speed, customization in a better success, right? I'm not developing from scratch. I'm using ready-made components that solve explainability, that solve monitoring, that solve retraining, that solve augmentation, that solve human-machine collaboration, annotation, feedback, validation, all these components together. And not all solutions need all of them, and different flavors, etc. But like when you build a class in Python, you have many different methods that you can put in. That's what I want to have, and I want to make sure that when I'm doing the customization, I'm configuring more than developing. right? So I want this and this and this with these parameters, do few experiments, send 100 experiments with different flavors, and boom, I have the right configuration. And then the engineering part of that, the deployment, the orchestration, combining all these pieces together must be generic as possible, right? Because that's otherwise it will be a significant bottleneck, right? Okay, I done this orchestration in the research side. It's now I have a pipeline. It's ready for deployment. I want to make sure that the deployment is more or less the same for any solution. That my UI that we give with each solution that do the monitoring and solution management is also almost identical, right? I don't want to go into developing a dedicated UI for each solution because it won't be scalable. I won't solve it in a lifetime. So these are the elements that we're taking into consideration when doing customization and orchestration, and it's definitely a combined element. And this is what makes our company and product scalable and makes sense as a SaaS solution that includes this maintenance and updates for our customers, make sure that the models are relevant over time. These are critical elements, I think, for any data science project, but definitely when you think about scale, about mass adoption of AI, when you look organization-wide, right? Think about an enterprise that think about AI strategy. Now, put yourself in the shoes of a CIO in a Fortune 1000 company that try to think about AI at scale, AI across the organization, from churn prediction in your CRM or your customer success through something completely over operation, email classification to triage, all over the place, right? There are so many different areas and flavors and use cases and application. What's common to all of these? And that's, of course, an ongoing development and research and questioning about the product and features that we're developing, and companies should address. But that's the big question. Engineering-wise, I think all these MLOps components are super critical, right? The serving of the models, how you wrap these. Clearly, CI/CD as part of it. I call it. I like to add CT or CL for continuous training or continuous learning into this system. When you think about that, going back into the retraining that we discussed earlier. So I think all of these elements are super critical, and you definitely need an architect.
Yeah, well, that's always the critical part. Like, how do you put the pieces together? I guess from what you said, I'm curious about two things. So one is a few episodes ago we had Julien from Hugging Face, and he said at some point that you could argue that the Hugging Face library, the challenge there is not a machine learning challenge, but an API design challenge. Like, how do you create an interface which works well and is generalizable enough so that people can use it very easily, and it doesn't provide a bunch of overhead and everything? It seems like you have a similar issue. Like, if you're building out these separate components and you want them to be sort of like Lego blocks, or you choose these are the things that I need for a specific project, and then it just works together. Like, do you have any tips for how to think about API design and like where the line is drawn between different components?
Well, I'm not sure I'm the best person to answer that question. Most of my career I done AI research, so that's the best area that I educated and know about. But on a nutshell, as far as I can understand and tell you from what we're doing, it's exactly about that, about thinking about the big picture and generalized problem, right? Because everything is solvable. You just need to understand what are the right requirements and constraints that you're going to have when generalized wide, right? And I think it's related also to a development, how you develop a product, right? If you are developing with full spec, or you do that step by step. Definitely, when when you build a new startup or new product, you want to make sure that you have feedback for customers. You make sure that you solve one customer, and then when the second one, you want to make sure that you solve for the second one, and from time to time, do this refactor, do this what is mutual, again and again and again and again, till it becomes something that is mutual and wide and strong enough to onboard a new customer with limited customization. So I think it's related to how to do that as well. I don't think there is rule of thumb solution for that. It's definitely a case by case, and we are still doing a lot of thinking around the design of that solution.
Okay, interesting. So maybe I'll skip to a question about like the team, which I think is related to all of this, because obviously the people making the magic happen are the engineers, the data scientists, the researchers. And like, as I said in the intro, you are sort of managing or working with a very varied team that includes researchers and ML engineers and data scientists. So, and maybe even classical software developers. One interesting question that has come up in past episodes is like, how do you measure success for each team within the organization?
That's another great question. Success can be measured in lots of different ways, and as a company that will deal with AI, we want to make sure that we are data driven as much as possible. But I think when it comes to people, measuring success for individuals and for team become complex. It has hard measures, right? That you can define different metrics and KPIs, but it has a lot of soft skills and elements: how we work together, how we communicate, what is the time to production, how much time it takes us to do this customization, how much time you need, how much time it takes to build a model, how much time it takes to orchestrate, how much time it takes to deploy, to onboard a new customer, and where are the bottlenecks. I think it's more important to understand this post perspective. That's maybe another topic. I highly believe in debriefing culture. I think it's one of the most important elements for a company or for a startup. But I think you want to make sure that you are measuring on different levels. That's something that is very computer vision wise. And I think the concept of different levels, different scales, do convolution in different scales over the image is exactly what you want to do when you measure productivity or measure success, right? You want to make sure that you're measuring individuals, sub-teams or project teams, process, and you want to measure that on success, on failures, which is one of the interesting one, time. So I think that's what we're trying to do at least. And it's not very easy, but it's achievable. Putting agile development into research is very, very helpful. Right?
If you succeed.
Well, there are so many different podcasts and articles that was written about how to deploy good development workflow and work process in research teams. So I'm not the expert. There are many books that was written about that, but from my experience, definitely possible. 100%. You can. It's just about good planning and make people used to this way of developing, right? You can definitely do a sprint of 2 weeks, well defined, and make sure at the end what we achieved, what we didn't achieve, and same as you do it in software. I wouldn't say that research and data science become fully democratized, but it's on the way there. And there are many different tools and things that are quite defined, right? You mentioned one of the most amazing APIs for developing, right? The amount of open source is tremendously large, right? In almost every solution that you develop will be this go-to, right? So you want to make sure that you are doing data analysis and literature review. It's quite well-defined problems, right? And then you want to build a basic workflow and data loaders, etc., and make sure that you are on track. This can be divided into a workflow, into different stations that you more or less know how much time they're going to take, right? There is this, let's say, de-research problem that, okay, there is option A, option B, option 3 that you need to test. And maybe after you test 2 weeks option A, you go back into the initial point and need to test option B. So it's not a complete queue of tasks, right? You have back and forth, but it's definitely possible. And Agile is dynamic, so that's exactly what we need. So I think, and there are so many KPIs for Agile development, etc., that can be used. This is my take on that.
So I mean, I mostly agree. I think as far as recommendations go, there's a really great talk by a guy named Dima Goldenberg. I think it's on YouTube. If it is, I'll add a link in the description. But he's a data scientist, team lead at Booking.com, and he has a talk about sort of working under something which is close to Agile in sort of a cross-functional team, where you have a data scientist, you have developers, and how do you manage that in a way where, like you said, there are some parts of the work which fit neatly into Agile and sprints and everything, but others that don't, and how do you resolve those conflicts? So I really recommend that. And I think that obviously, like, measuring success is like you say, it's very dependent on what level you're looking at, and as the further you go down towards the personal level, then it's more personal, because everyone is a bit different and are, I don't know, better or not as good at certain things. But I think you also mentioned one metric which I find interesting. So last episode we had the discussion about whether or not having more models in production within a company that has good practices is a good measurement for success. You mentioned this earlier as well, like Facebook having thousands of models in production, and Facebook is obviously one of the extreme cases of a company who's has a very successful machine learning team. But you also mentioned now the time to production, which I think is arguably harder to measure. It's not like this one number that you can look at in your cloud account and see how many instances you have. But it is measurable. And especially if you measure it from given states, like when you start a task or when a model has failed until you deploy the new version of that model, I think that's interesting, and it might be a good indicator of success for, again, all of the teams involved.
I think time to production is very important to measure. For us, it's critical. Our scalability and our entire platform model is based on the time to production, right? Definitely if you take into consideration the customization that is needed. So time to production is critical.
Would you say that do you have benchmarks for the changes that you see? Like, maybe not in absolute numbers, maybe that's sensitive information, but like, how many gains have you seen? And I'm talking internally, so not for customers, but for you, for getting a new version or a new model into production.
It's a tricky question because of the complexity level that is changing between solutions, right? And if the complexity level is changing, that must be normalized somehow.
Yeah.
I do think that it's achievable to, well, I don't know. It's a risky say. I think probably most practical application are achievable to put in production under 6 months. And take into consideration that the standards today are around, I think, between 14 and 18 months. The last survey that I read. So I totally think that it's possible to do within 6 months.
So
Even
this would be a
complex,
measurement for
problems.
like a company that's now starting a project from scratch or something like scratch and then deploying it to production.
I believe so. When we are starting a new solution for a customer, we're planning the time to production. We're planning the entire customization steps that needed, the integration, the milestone, the meetings with the clients, when that's going to be first in production, first data, all the components that are needed besides building the model. So we try to plan that. And of course, when you plan, you can measure yourself.
Yeah, that makes a lot of sense. Maybe for recommendations, I'll ask one more question about, again, like team distribution and responsibilities. So how do you divide the work between researchers, ML engineers, and if you have traditional software developers or data scientists, like all the technical roles in the organization? Who's responsible for what?
That's a hard one. Well, we have in the company two different departments: engineering department and or a group, and the research group. And the ML engineer is the bridge between them, or ML ops team, helping to take models, wrapping them in a way that they will be deployable. Combining these elements in a systematic way. And of course, we have software. Software is critical. We have UI that comes with everything. We have development environment and production environments, and lots of DevOps work that is needed, QA that is needed. So there are many, many different components. I don't think actually that bringing AI to production is very far than bringing any other software to production. It's have models, okay. The research is needed, but research is needed in everything related to algorithmics. You need algorithmic team. Okay, so in AI we call them researchers, but not everything is solvable also in software or in DevOps or in QA, or everything is it's a classic software development pipeline.
Fair enough. I would argue that one of the signals that you're working on a real, like you've passed all of the solved problems, is that you start to realize where you start to have challenges where there is no right solution. It's just a trade-off, and you need to decide what you care about more, and you're not going to be able to hold both ends of the stick. So that's a good signal that you're actually working on like really hard problems, and that's okay. I mean, again, in software there are a lot of problems. You have to decide what you prefer, and that's what you get, and then you either target specific audiences that care about the problem that you are solving, or you, I don't know, create two different solutions, each solving a different problem. Okay, awesome. So let's finish with I don't know, either things that you're learning currently or have recently learned, or recommendations for the audience, and they don't have to be data science related.
Well, I have a very easy recommendation, which I think I'm trying to do all the time. Well, it's paper a day. I think paper a day is about learning. It's about being creative. It's about exploring. So I know reading papers is a time-consuming task, but can be more and more efficient with time. I think it's one of the most important things that you learn from doing a PhD is how to read papers or scan papers fast. probably the best skill that you learn from PhD. But I think it's critical in people that work with AI to read papers. Unlike many other domains, the industry and the academia are very much connected in AI. And there are so many papers and so much open code, open source. By the way, reading a code in many cases is considered to be reading a paper for my in my point of view. And so you can read code as well. I think it's very you can learn a lot from it. So paper a day. That's definitely the best recommendation that I can give.
How often do you do this?
Paper a day, every day.
It's paper a day. Okay, so like
Paper
every
a
day.
day.
Wow. Okay,
Yeah.
that's impressive.
It could be 5 minutes.
Yeah.
I think 15 minutes is achievable, ideal. Spend 15 minutes in reading a paper. Look at the abstract, look at the figures, scan some interesting areas. Maybe look a bit deeper into the methods. If needed, if it's super interesting, take 1 hour. But that's my rule of thumb.
Do you also count watching 2-minute papers, or is that does that
not
count?
Not yet, but I'm not doing that. But I think it's not a bad way. It's not a bad way. Yeah, and listen to podcasts. That's also important. I think I live in London, and in the last 18 months almost, we used to work from home. Now we're back to office finally, and I think one of the biggest advantages of going back to the office is driving the tube, or not driving, commuting to work in the tube and be able to listen to podcasts. That's something that I love in my daily routine.
Do you have any specific podcast that you like the most?
Sorry for the non-Israeli, non-Hebrew audience, but I love Chayot Kiss, which is an amazing podcast.
Fair enough. So those are great recommendations. If we're in podcasts, I'll recommend a podcast. So I think I already recommended this once, but Slate Star Codex, which is now renamed to Astral Codex 10 podcast. It's technically a blog, but it's so popular that some person who is not a blogger is reading it out. Reading it out and turned it into a podcast. It's really great. The guy is very prolific, so there are multiple episodes every week. So you have to decide which ones you want to listen to, but it's really good. And then just in our realm, if you're not familiar with it, the Data Engineering Podcast is a nice podcast about, unsurprisingly, data engineering, which is really great. If you want to keep up to date, not just with research, but also with technologies that are relevant for the data and machine learning fields, that is a great place to do it. And that's it. Roey, thank you very much for your time. It was a pleasure having you here, and hopefully we can do this again in the future.
Yeah, thank you, Dean. It was a lovely discussion, and thank you for hosting.
Okay, bye everyone.
Bye-bye.
Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.